In this video, we'll show how to do the questions in Module 2 of the math portion of the SAT Practice Test number 9, published by the College Board. You can find the questions in this video by finding the practice test online. The test is published by the College Board. You can search College Board SAT Practice Test in an internet browser, or you can go directly to the website you see on the screen. A link to this website will be in the description of this video. I'll also link the PDF of the practice test in the description of the video as well. If you go to that website, this is going to be bundle 9 of the paper practice test. If you click on that, you can find the paper practice test here. You can also find answers and written explanations of the answers in that bundle. Some of the written explanations will be different than the explanations I show in this video. Once you download the SAT practice test, it will look like this. It starts out with reading and writing modules, and then it goes into math modules. Module 2 begins on page 38. The first page of the module has a formula and fact sheet. The second page of the module describes how to format the answers when you write them down. And then the question starts. Again, this video covers Module 2 of Practice Test number 9. There'll be a link to Module 1 of Practice Test number 9 in the description of this video. So let's do the questions. Question 1. What value of W is the solution to the given equation? We have the equation W plus 7 is equal to 357. What I would do is I would subtract 7 from both sides. If we subtract 7 from both sides, we get W is equal to 350. And that's what it's asking us for. So the answer to question number 1 is B, 350. Question 2, which expression is equivalent to 16 times, in parentheses, x plus 15? Well, all we have to do is take that 16 and use the distributive property. I would to multiply it times both terms inside the parentheses. So 16 times x would be 16x. 16 times 15 becomes 240. Therefore, the final answer is 16x plus 240. That is answer B. So B is the answer to question number 2. Question 3. The table summarizes members of a local organization by age and whether they live east or west of the river. If a member of the organization is selected at random, what is the probability that the member is at least 40 years old? So what we do is we're asked to use essentially classical probability to figure out the probability of being selected at random, of selecting someone at random, and that person being at least 40 years old. So at least 40 years old, we can find that probability by taking, since we're selecting at random from the whole group, my denominator is going to be 135. That's the size of the group. The numerator is going to be the number of individuals who are at least 40. You can see that the total number of individuals who are at least 40 is 107. So the probability of being at least 40 in this data set is 107 divided by 135. And that answer is D. So D is the answer to question 3. Question 4. The solution to the given system of equations is x comma y. What is the value of y? There's a number of different ways that we can go about solving this. We could have solved this first equation for x and then plug the number in. But what I think I will do is I will use the elimination method because the coefficients of x are opposites. So if I just add these two equations up, add the left-hand side of the first equation to the left-hand side of the second equation, I get y. Adding the right-hand sides together, 12 minus 6 gives me a positive 6. So just adding those two equations up together using the elimination method gives me y equals 6. That means the solution to this system of equations is going to have y value of 6. And that's all we're asked to find. So if we have a solution, what's the y value of that solution? Therefore, the answer to question 4 is B, 6. Question 5. A line in the xy plane has slope of 1/9 and passes through the point 0, 14. Which equation represents this line? So if we're thinking about a line, the easiest way to think about a line in this scenario is to take slope-intercept form. Y equals mx plus b. That's slope-intercept form where m is the slope of the line and b is the y value of the y-intercept. So notice that this gives me the slope of the line as 1/9. So it's going to look like y equals 1/9 times x. And then it turns out this point that they give is the y-intercept. It's what I get when I plug in x of 0. When I plug in x of 0, I get 14. So that's the point that crosses the y-axis. That's the y-intercept. And therefore, my b is 14 as well. So y equals 1/9 x plus 14. And therefore, the answer to question 5 is D. Question 6. In the figure shown, line C intersects parallel lines S and T. What is the value of x? Well, for this one, I'll draw on this. Basically, since S and T are parallel, then the angles of intersection are going to be the same. In other words, this angle x, which is right and a top line S, is going to be the same angle that is on the top right-hand side of line T, between line T and C. So x is going to be this value, or if you look at above and to the left, that angle is 110, above and to the left of T. So we can think of this angle above and to the left of S, where it meets line C, as also being 110. In either case, what we have is that x and 110 are both on a straight line, either S or T. And therefore, knowing that the angle of a straight line is 180 degrees. We have 110 plus x is equal to 180. And that means the x value is 70 or 70 degrees. This one says, what is the value of x? Well, x is 70. So the answer to question 6 is 70. Question 7. The function f is defined by the given equation. What is the value of f of x when x is equal to 3 over 11? So basically, we're plugging in 3 over 11 into my function f. That is just going to be x plus 8/11. X here is 3 over 11. So I take 3 over 11. I won't write that in parentheses. 3 over 11 plus 8 over 11. And when you add fractions with common denominators, you just add the numerators. We get 11 over 11. You can also use your calculator to do that. And 11 over 11 is 1. So the value is 1 when the value of f of x is 1 when x is equal to 3 over 11. And that's it. That's the final answer. Answer to question 7 is 1. Question 8. The table shows 3 values of x and their corresponding values of y. There is a linear relationship between x and y. Which of the following equations represents this relationship? So if we know that there's a linear relationship, all of these equations are in the form y equals mx plus b. That's the slope-intercept form. So what I would do is I would start out finding the slope. We can find the slope by taking change in y divided by change in x. So imagine that 113 is my second point and 018 is my first point. I would find the slope by taking the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. In this case, that's going to be 13 minus 18. Again, first point is 018, second point is 113. Divided by 1 minus 0. When you do that calculation, you get negative 5 over 1, which is just negative 5. And then we can see that the y-intercept is the point 018. Just that's the first point that we're given. And so the b value is going to be 18 as well. So that's what we have. That means the equation of the line is going to look like y equals negative 5x plus 18. That's the equation of the line, and therefore D is the answer to this question. So D is the answer to question 8. Question 9. Which ordered pair is a solution to the given system of equations? Now, you can do this in a couple ways. You can plug in all of these ordered pairs and just check them if you'd like, or you can solve this system of equations because it's actually pretty easy to solve. So in the first equation, we have x plus 7 is equal to 10. That means the only solutions are going to have x value of 3 because subtracting 7 from both sides gives me an x value of 3. In order to figure out what the corresponding y value is, We're going to take the second equation and we're going to plug in 3 into x. Since x equals 3, we're going to take in parentheses 3 plus 7, that's going to be 10 squared, and set that equal to y. 10 squared is 100, so we end up with a y value of 100. So that means the only solution to this system of equations is 3, comma, 100. So the point 3, comma, 100 is the solution to question 9. And that is option A in the answer. So A is the answer to question 9. Question 10. The function f is defined by f of x is equal to 7x minus 84. What is the x-intercept of the graph y equals f of x in the xy plane? Well, the x-intercept is going to be what I get when I plug in a y value of 0. So all I have to do is set the y value equal to 0. The y value is the output value, so set 7x minus 84 equal to 0. Adding 84 to both sides gives me 84 equal to 7x. Then dividing both sides by 7 gives me a 12. X equals 12. So therefore, the x-intercept is the point where the x value is 12 and the y value is 0. So that's my x-intercept, and that's clearly option D. So D is the answer to question 10. Question 11. Rosa opened a savings account at a bank. The table shows the exponential relationship between the time t in years since Rosa opened the account and the total amount in dollars of the account. If Rosa made no additional deposits or withdrawals, which of the following equations best represents the relationship between t and n? So this is knowing something about an exponential function. An exponential function is going to look like n equals some coefficient times a base raised to a power. In this case, our power is t because we're talking about t, years. When we plug in 0, time of 0, we're going to get a 1 with the b of t, and we want the amount of dollars to be 604. So I want that a value, that coefficient, to be 604. What's the base going to be? Well, we could find it by plugging in 1 and seeing that it gets you to 606.42. So basically take the base, solve it by plugging in 1 for t, and seeing that the amount gives us 606.42. When you take 606.42 and divide it by 604, you get 1.004. So we get base raised to the first power is 1.004 roughly. The base raised to the first power is just the base itself. So that's what we end up with. So that means our equation is going to look like n equals 604 times 1.004 raised to the tth power. And that's option C. So option C is the answer to question 11. Question 12. The function W models the volume of liquid in milliliters in a container T seconds after it begins draining from a hole at the bottom. According to this model, what is the predicted volume in milliliters draining from the container each second? Well, T is in seconds. And what this is saying is essentially we're going to start at 300 because when you plug in 0, you get 300. And then when T hits 1, 4 milliliters go away. When T hits 2, 8 go away. So every single second, we're losing 4. Another way to think of this is that the slope is -4. So we're draining. If you notice that this is a linear function with slope of -4, that means we're draining 4 milliliters per second. And therefore the answer to 12 is D. We're draining 4 milliliters per second. Slope is -4, so 4 is going away each second. Question 13. For the linear function h, b is a constant and h of 0 is equal to 45. What is the value of b? Well, if the output is 45, when we plug in a 0, I know that the output of this function is going to be x plus b. So if I plug in a 0 for x and add b, I end up with output 45. That's what h of 0 equals 45 tells me. Solving for b, well, the 0 plus b is just b. So b has to be equal to 45. And that's the answer to question 13. 45 is the value of b. Question 14. What is one of the solutions to the given equation? So this is a quadratic equation, and therefore what we would do is we would solve this. There's a couple of different methods you could use to solve this. You could use completing the square, you could use the quadratic formula, or the method I like best, if it applies, is factoring. In this case, this will factor. We have z plus a number times another z plus a number equaling 0. The numbers that need to be put into these two slots need to multiply to give me -24 and add to give me a +10. So if I put in a 12 and a -2, 12 times -2 multiplies to give me a -24 and add to give me a +10. Now we have the left-hand side factored and set equal to 0 on the right-hand side. So I can use the 0 factor property to say that z plus 12 has to be 0, or z minus 2 has to be 0 in order to make this equation true. So subtracting 12 from both sides gives you z is equal to -12, or adding 2 to both sides on the second one would give me z is equal to +2. Now 14 is just asking for one of the solutions to the given equation. So you can actually either put the negative 12 or you could put the 2 as the solution to question 14. So either way actually works because it's only asking for 1. So you can pick negative 12, that's one solution, or 2, that's another solution. '15. Triangle FGH is similar to JKL, where angle F corresponds to angle J, and angles G and K are right angles. If sine of F is equal to 308 over 317, what is the value of sine of J? Now you could draw a picture if you'd like, but it's actually not necessary in this scenario. Similar triangles mean that the angles will be equal. So since the angles are going to be equal, I should say corresponding angles are going to be equal. Since the corresponding angles are going to be equal, and I know F corresponds to angle J, that means angle F is going to be the same as angle J. Well, because of the way sine works, that means sine of F is also going to be equal to sine of J. But I know sine of F is 308 over 317. So since sine of F is equal to 308 over 317, this forces sine of J to also be 308 over 317. And that's it. So B is the correct answer to question 15. Sine of J is equal to 308 over 317. Again, you could have drawn a picture if you'd like, but the picture doesn't do a whole lot. As long as we know similar triangles means corresponding angles have to be equal, we can solve this problem. Question 16. The population of Greenville increased by 7% from 2015 to 2016. If the 2016 population is K times the 2015 population, what is the value of K? So we're saying the population in 2016, I'll just say that, is equal to some K times the population in 2015. I'll use subscripts for population in 2016 and population in 2015. What is the value of K? Well, an increase by 7% means a multiplication by 107%, which as a decimal is 1.07. And that means we would have to take the 2015 population, multiply it times 1.07 to get the 2016 population. And therefore, K is equal to 1.07. And that's what 16 is looking for. So the answer to 16 is 1.07. We need to multiply by 1.07. And that's obviously answer C. Question 17. Each of the dot plots shown represents the number of glue sticks brought in by each student for two classes, Class A and Class B. Which statement best compares the standard deviations of the number of glue sticks brought in by each student for these two classes? So the standard deviation is how spread out the data is. Notice that while these numbers on the x-axis are different, the gaps are the same. So 1 to 2 is a gap of 1. That's the same gap as 14 to 15. So all of these are jumps by 1. All of those are jumps by 1. If I'm looking at how spread out the data is, well, these dot plots are giving me the exact same distribution. Other than one is shifted over from the other. In other words, one starts at 1, the other starts at 14. But the shape is the exact same. The gaps between are the exact same. And that means the standard deviation of each group is the same. And so we just need to pick out which statement matches that the best. And it turns out that that's statement B. The standard deviation of the number of glue sticks brought in by each student for Class A is equal to the standard deviation of the number of glue sticks brought in by each student for Class B. This one is less than, A is less than, B is greater than, D is not enough information. B is the same, so B is the correct answer to this question. That's question 17. Question 18. The function m gives the predicted body mass, m of t, in kilograms of a certain animal t days after it was born, where t is less than or equal to 390. Which of the following is the best interpretation of the statement m of 330 is approximately equal to 362? So it doesn't even matter what this is. We know that m of 330 is equal to 362. M is the predicted body mass, and T is the number of days after it was born. So basically, this is saying that 330 days after the animal is born, the body mass is going to be 362, and that's in kilograms. So when you plug in 330 into T, T stands for number of days after it was born. 362 is the output of body mass, and so that's what it's telling us. So we just look at the most appropriate option there, and that would be B. The predicted body mass of the animal was approximately 362 kilograms 330 days after it was born. So B is the answer to question 18. Question 19. Triangle XYZ is similar to RST such that X, Y, and Z correspond to R, S, and T respectively. The measure of angle Z is 20 degrees. 2 times XY is equal to RS. What is the angle? What is the measure of angle T? Now, once again, if we wanted to draw a picture of XYZ and a similar triangle RST, we know similar triangles have corresponding angles which are the same. So when it says X, Y, Z correspond to R, S, T respectively, that means angle X is going to be the same as angle R. Angle Y is going to be the same as angle S. And angle Z is going to be the same as angle T. If I know that Z is equal to 20 degrees, well, since Z and T are the exact same, then I know T has to also be 20 degrees. So what is the measure of angle T? I didn't even need to draw the actual triangles. I know that C is the correct answer for question 19. 20 degrees, which is C. Question 20. The function f of t is equal to 60,000 times 2 raised to the t over 410. That gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? So a double is a multiply by 2. We start with 60,000. We want to get to 120,000. So we need to multiply by 2. Here our base is 2, and we're raising that to the t over 410 power. So basically, I just need t raised to the, 2 raised to the t over 410 to actually be equal to 2, or 2 to the first power. And that just means t over 410 needs to be equal to 1. And so t would have to be 410. You can either think of solving that by making this fraction 1 or multiplying both sides by 410. So that t is in minutes. Therefore, the answer to this question is that it's going to take 410 minutes for the bacteria in this population to double. Doublings multiplying by 2, that meant this exponent had to be equal to 1, which meant t has to be 410. So 410 is the answer to question 20. Question 21. The function f is defined by f of x is equal to a raised to the x power plus b, where a and b are constants, a is greater than 0. In the xy plane, the graph of y equals f of x has a y-intercept of 0, negative 25, and passes through the point 2, 23. What is the value of a plus b? So let's start with the y-intercept first. This says if you plug in 0 into the function, we're going to get out an output which is negative 25. So let me write down the function again. F of x is equal to a raised to the x power plus b. So we get out an output of negative 25 when x is 0. Since a is a constant and a positive constant at that, a to the 0 is going to be 1. So negative 25 is equal to 1 plus b. Subtracting 1 from both sides gives a b value of negative 26. So now I know what the b value is. And I know that my function f of x is going to look like a raised to the x power minus 26. Now I know that this function also passes through the point 2, 23. That means the output is going to be 23 when the input is 2. So I can solve for a here. Adding 26 to both sides gives me 49 is equal to a squared. Now, normally, algebraically, I'd have to take a as the positive square root of 49 and the negative square root of 49, but this tells me that a has to be positive. So I know a is going to be the square root of 49, which is 7. So there we go. Now I know that my function is actually 7 raised to the x power minus 26. Now, that's not what my question asked for. The question is asking for what is the value of a plus b? Well, so to answer that, a plus b is simply 7 plus negative 26. Which is negative 19. And therefore, negative 19 is the answer to question 21. So negative 19 is the answer that we're looking for. We're looking for the value of a plus b, and that value is negative 19. Question 22. For which of the following tables are the values of x and their corresponding values of y solutions to the given inequality? So in other tests, I've plugged in numbers and checked numbers. That's what I'm going to do here, but I'm going to do it in a maybe a little bit more clever way, hopefully. Notice that the x values are 3, 5, and 8 for each case, and we get different y values for each case. So what I'm going to do is I'm going to take this inequality, which says y is greater than 13x minus 18. And instead of plugging in specific x and y values, I'm just going to plug in an x value of 3 and see what happens. If we have an x value of 3, then our corresponding y value has to be greater than 13 times 3 minus 18. So that means our corresponding y value has to be greater than 21. Now, if you notice on these tables, option A is not going to work because when we have a 3, we get exactly 21 as our y value. We need a y value bigger than 21. Also, option C is not going to work because when I plug in a 3, I get a number which is smaller than 21. And therefore, A and C don't work. So I know that for sure. So that's just by, oh, bless me, plugging in x equals 3. Let's do the same thing for the next number. Let's plug in x equals 5. If we do that, we'll get y is greater than 13 times 5 minus 18. 13 times 5 minus 18. Well, that is a 47. So I'm just going to simplify that. So when x is equal to 5, y has to be greater than 47. By the way, since A and C don't work, I can ignore A and C, and I can look at B and D. Notice that when we plug in 5 in the B spot, we get a 42. 42 is not greater than 47, so B does not work. But D does. So D works. Now, at this point, we've kind of established that D is our only option for working. But if you wanted to check that last point as well, you could do that. Just go ahead and plug in an x equals an 8. We would end up with y greater than 13 times 8 minus 18. And 13 times 8 minus 18 is 86. Obviously, that works for option D, so table D. So the only table where plugging in all 3 values works is D. So D works for all x values that are given. And so D is the correct answer. D is the table that works. So there you go. The answer to question 22 is D. Table D is going to have solutions to this inequality. Question 23. A certain town has an area of 4.36 square miles. What is the area in square yards of this town if 1 mile is equal to 1,760 yards? Well, if 1 mile is equal to 1,760 yards, then what I need to do is I need to square both sides to get a conversion for square miles and square yards. If I square the right-hand side, square 1760, I end up with 3,097,600 square yards. And so if I'm converting from square miles to square yards, we take 4.36 square miles and then multiply that times a fraction that is of size 1. So you take 3,097,600 square yards over 1 square mile. So multiply times a fraction that's 1. The square miles cancel out and we'll be left with square yards. So we get 13,505,536 square yards. is the size of the town. And therefore, the answer to question 23 is D, 13,505,536. Question 24. A square inscribed in a circle. A square is inscribed in a circle. The radius of the circle is 20 times square root of 2 divided by 2 inches. What is the side length in inches of the square? Now, this one is going to be best if I draw a picture so I can see what's going on. So I'm going to draw a picture and then drop it in to this Word document. So this is the picture, and I've added a couple of labels. First off, we can see that we have a square inscribed inside of a circle. The radius of the circle is 20 times square root of 2 over 2. Now, the radius of the circle is going to be half the diameter. That's always the case. But notice that if we draw from corner to corner of our square, we get the diameter of the circle. So the diameter of the circle we know is twice the radius. And in this case, we know that that is 20 times the square root of 2 divided by 2. That's the radius. So if I take twice that number, I see that the diameter is equal to 20 times the square root of 2. So that's the diameter of the circle, which is also the diagonal of the square. Now, because it's the diagonal of a square, it breaks this square up into 2 right triangles. And because angles of a square are 90 degrees, when we break it up into 2 right triangles evenly, we get 45 degrees and 45 degrees. So this diagonal of the square is the hypotenuse of a 45, 45, 90 right triangle. Now you can use Pythagorean theorem if you'd like, or you can use the special 45, 45, 90 degree right triangle if you like. Both will give you the side lengths now. I think I'll do both options just so you see both options. But I want to point out that the 45, 45, 90 right triangle is one of the special right triangles provided on that formula sheet at the beginning of Module 2. Let me show you that. So here's special right triangles. We have 45, 45 degree right triangles, and it says whenever I have that, then if the legs are length S and the hypotenuse is length S times square root of 2. So that's one option that we can use to find the lengths of the sides of the square. The other option is to utilize the Pythagorean theorem, knowing that A and B are both S in this case. So if we use the special right triangle, then I know that the side of the right triangle, so special, has the property that S times the square root of 2 is equal to the hypotenuse, which is in this case our diagonal, which is 20 times the square root of 2. And that means the side lengths of my square, which are the legs of the right triangle, is equal to 20. And that's it. That's option A, and then we'd be done. On the other hand, if you'd have rather used the Pythagorean theorem, the Pythagorean theorem says a squared plus b squared is equal to c squared, where c is the length of the hypotenuse and a and b are the lengths of the legs. So in this case, we already know that the legs are both s and the hypotenuse is 20 times square root of 2. So if we do the calculations there, what we're going to get 20 times 20 times 2 gives me 800. So we get 2s squared is equal to 800. Dividing both sides by 2 gives me an s squared, which is equal to 40. And then square root at both sides. Again, we have to have positive lengths. So in this case, s would have to be the positive 20. So whether you want to use special right triangles or whether you want to use Pythagorean theorem, both cases show that 20 is the length of each side of this square. So A20 is the answer to question 24. Question 25. Which expression is equivalent to y plus 12 over x minus 8 plus y times x minus 8 divided by x squared y minus 8xy? So this is asking us to add together two fractions where we have polynomial pieces in the numerator and denominator. There's different ways to do this, but what I like to do is I like to factor the denominators. So I'm going to factor the x minus 8. I've already got that factored. There's no factoring. There's no greatest common factor between x and 8 other than 1. And then I'm going to factor this other denominator. Notice that the greatest common factor here is x times y. If I pull out an x times y, I'm left with an x as the first term and a minus 8 as the second term. So that means if I multiply this left-hand equation by xy on top and bottom, so I'm multiplying by 1, then I'm going to get a common denominator. Now, when I do that, I need to make sure that the y plus 12, both terms there, get multiplied times the xy. So that's what I'm going to do. Xy times y is x times y squared. 12xy is 12xy. That's going to be divided by xy times 8 minus x. And then on the other side, I will also multiply the numerator. Y times x and x times y is the same, so I'll call that xy minus 8y divided by xy divided by x, or times x minus 8. Since I have the same denominators, I can add the numerators. When I add the numerators, 12xy and another xy combine to give me 13xy, but that's the only thing I can actually combine. So I get xy squared plus 13xy minus 8y on top. And then on bottom, I'd get xy times x minus 8. So that gives me my fraction as a, this expression as a single fraction. Now you'll notice in all of my options, the denominators have been multiplied out. So I'm going to go ahead and multiply out this denominator as well. So xy times x is x squared y. Xy times minus 8 is minus 8xy. So we get x squared times y minus 8xy in the denominator. And if you look at that expression is the same as C. Therefore, C is the answer to question 25. So 25, the answer is C. Question 26. The function f is defined by f of x is equal to a times 2.2 raised to the x power plus 2.2 raised to the b power, where 2.2 raised to the x plus 2.2 raised to the b is in parentheses. A and b are integer constants that are both above 0, and b is bigger than a. The functions g and h are equivalent to function f, where k and m are constants. Which of the following equations displays the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane as a constant or coefficient? So we're looking for the y-coordinate of the y-intercept of this graph f of x. If I'm looking for the y-coordinate of the y-intercept, that is going to be what I get when I plug in 0 into the function. When I plug in 0 into the function, I get 2.2 times x, or excuse me, 2.2 raised to the x power plus 2.2 raised to the b power. That's the function, so I'm going to plug in an x of 0 there. So the y-coordinate of the y-intercept is going to be a multiplied times 1 plus 2.2 raised to the b power. That is the y-coordinate of the y-intercept. So then I look at my two functions, g and h, and I ask, are there ways that g or h displays this value as a constant or as a coefficient? Well, the coefficient in both of these cases is a. That's clearly not this number, because this number is a times something. B, remember, whoops, b was greater than 0. So this isn't going to go to 0 or anything. So this is not a coefficient in either case. Now, the other scenario is what happens. So it's not a coefficient in either case. It's also not going to be a constant in either case. If you were to plug in 0 into g or plug in 0 into H. Let me just do that. Plugging in 0 into G would give you A. 2.2 to the 0 power is 1 plus K. So that K constant is not this. In fact, K would have to be 2.2 raised to the B power if G of 0 were the same as F of 0, which it says it's the same. So that would force my constant not to be this Y value, this Y coordinate, but rather my constant would have to be 2.2 raised to the B power. In a similar way, if I plug in 0 into H, I get A plus M. And in this case, so first case, K was forced to be 2.2 raised to the B power. In this case, if I distribute the A times 1 is A times 2.2 to the B is A times 2.2 to the B. So M would have had to have been A times 2.2 raised to the B power, which is also not the Y coordinate of the Y intercept. So K is not the Y coordinate of the Y intercept. M is not the Y coordinate of the Y intercept. And then coefficients are not the Y coordinate of the Y intercept. And that means neither G or H, so neither 1 nor 2, displays the function where the Y coordinate of the Y intercept is either the constant or the coefficient. So A is not the Y coordinate of the Y intercept. K is not the Y coordinate of the Y intercept. M is not the Y coordinate of the Y intercept. So neither of those two functions display what we're asking. And therefore D is the answer. Neither 1 nor 2 will work. Question 27. In the given equation, K is an integer constant. If the equation has no real solution, what is the least possible value of K? All right, so no real solution. Let's start by simplifying this. Distribute that X, we'll get KX squared minus 56X is equal to negative 16. And then I'll add 16 to both sides, so we get a quadratic equation. So we want this quadratic equation to have no real solution. Well, what is the solution? What are the solutions to this quadratic equation? I can find the solutions by using the quadratic formula, which is opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, the only way we get a no real solution is when this part under the square root is negative. So no real solution if that part under the square root is less than 0. So we just need to test when is that happening. B is obviously the coefficient of our X, C is our constant, and A stands for the coefficient of the x squared. So plugging in a b of negative 56, an a, which is just our variable k, and a c of 16 gives us this. 56 or negative 56 squared is 3,136. Then I get minus 64k less than 0. Adding 64k to both sides gives me 3136 is less than 64k. Then we can divide both sides by 64. And when I do that, I get 49 less than k. Now be careful about this. K has to be an integer constant. And we're saying, what is the smallest possible value of k to give us no real solution? 49 would give us exactly one real solution. We need our k to be bigger than 49. So the least k is actually 50. All right. We need our k to be an integer, which is bigger than 49. It can't be equal to 49. So if it's equal to 49, we get one real solution. Therefore, my k has to be 50. And that's it. 50 is the answer to question 27. There's no multiple choice. It says, what's the least possible value of k? Least possible value of k is 50. So that concludes Module 2 of the SAT Practice Test number 9 published by the College Board. If you want to do Module 1 of SAT Practice Test number 9, there'll be a link to that video where I work out all of the answers to the Module 1 in the description of this video. There's also a link to a playlist with other math portions of the SAT practice tests as well. So practice tests 1 through 10, there'll be a playlist of both modules of each practice test from 1 through 10. Lastly, if you are planning on taking the SAT soon, good luck. I hope this video helped you out.